Hello, everyone. Welcome to the Tuesday office hour. Sorry I'm a few minutes late. As per usual, if you have any questions to share with me in the live chat, please do so. I've also already opened up the new questions since yesterday on the discussion board. So we have a question about the VC question 5, and there's an answer that indicates something about the golden ratio. So k-means clustering doesn't really have very much to do with the golden ratio, but if we search for VC5, I have provided some explanations of k-means in the past. So I'll open up a few previous questions about the k-means algorithm, and maybe we can find something helpful that we can refer this student to. Da, 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 da. Many students have asked questions elaborating on different parts of the k-means problem, i.e. VC number 5. Please refer to previous questions and answers for posting new questions. Additionally, when posting a question, be sure to be specific about what you are finding difficult to understand. I remember doing a long write-up about how k-means works. And that's sort of what I'm looking for at the moment. I wonder, I feel like it should be possible to do a search based on user, but I'm not actually sure. Those are my questions. 142 answers. Okay. So maybe I can just look through these. I suspect it would be much easier to find if there weren't so many duplicate questions and if they were titled a bit better. Okay. Okay, so sorry, that was like a lot of dead air. I'm like really resistant to the idea of repeating myself. So first of all, let's just get a link to this question. You may want to start here. Notice in my question, I also link to a previous office hour, office hour 7, where I discuss this algorithm in detail. Other questions that may be helpful are this one. This question may also be helpful. Okay, and I'm gonna close this because this is absolutely a duplicate. It's very vague, but many students have asked about this question already, and there's a wealth of material on the discussion board and in the office hours addressing how to understand the k-means clustering algorithm, not mentioning the what's stated in the instructions. Okay, someone is having a difficulty with DW6, so they're grouping their prescriptions by the BNF codes and counting them. Okay. Rates, count divided by rates, count sum. Rare codes, BNF code, where rates are less than 0.1p. I think this looks reasonable. It's not exactly how I would do it. I think it's maybe a little overcooked. But it looks reasonable. Yep, so I'll give this my stamp of approval. Whoops. More complex test cases between Python and Excel, and forgot to reset the points to empty for both cluster A and cluster B after calculating the updated centroids. Since setting self.points to empty list should happen every time we run the update method, I would recommend instead of having a dot points equals blah, b dot points equals blah. This is, let's see, 1, 2, 3, 4. There we go. Simply including self.points equals in your update method after you calculate the update to self.center. Okay, so first of all, a grade of 0.75 is not bad. Remember, you only need an average of 0.9 to receive an honors distinction on your certificate. By getting a couple of 1.0s, you can easily balance out a 0.75. However, if you do not complete all the questions, then you will receive no certificate. It is better to spend your time working on finishing all the problems than perfecting solutions to individual problems. This is advice I have given several times here and there, but many students spend hours working on solutions that are already reasonably good. Let's now turn our attention to your problem. Okay, so they have items by post, group by field, joined postcode items. Assuming that this works correctly, they then iterate through this, but this postcode is going to be probably both of these things? I don't know. I don't know how they define this function, so I don't know exactly what it does. Anyway, they sum up items. Presumably for each postcode. You get their keys and values. For I in range 100, keys append. Okay, this would be the same as just taking a slice of the first 100 things from this, but first of all, all of this is equivalent to keys equals list items by code keys 100. Vals equals list items by code values 100. We don't need to iterate over a data structure to retrieve its elements. If we are iterating over a data structure, then we should iterate over it directly. For example, for key in K or for V in vals. You do this in your dictionary comprehension with for postcode items in items by post.items. In fact, you could collapse your entire code down to this right here. Items by code. Okay, I'm going to assume that meant item sum. Assuming items by code is supposed to be items sum, since items by code is not shown anywhere in the code you provided, however, your code also contains logical errors. For example, you take the first 100 elements prior to sorting. That means you won't get the 100 alphabetically first elements. You'll just get a random selection of 100 elements that get alphabetically sorted afterwards. It's possible your solution contains other mistakes, but without knowing how your group by field function works, or whether your use of items by code is a typo or in some way significant, it's impossible to comment further. Okay, this is difficult to read. I cannot get z-score for National Enhanced Service to be 11.6. I am getting 10.9. I must be doing something wrong. I am using counts of prescriptions. Should I be multiplying by items or quantities in the prescriptions? Neither. It's just counts. Not saying that the numbers he has here is right. I don't know if it's right, but also 11.69 minus 10.93.76 divided by 11.68. Okay, so that's just over the 5% threshold to actually get that question wrong. This is supposed to be 6. That's the only thing I can come up with. Okay, I'm gonna check if that's meant to be 6 or not. Okay. So practices name equals, and what was the name of this one? National Enhanced Service. So that's code Y01852. Yep, 6 out of 7. Okay. Then scripts, opioid, standard deviation. My standard deviation is different than his. Which means my mean most likely is as well. Yep. My total percent of opioids and standard deviation is different than yours. Both quantities are lower. It seems possible that some of your prescriptions are getting flagged, are either A, getting flagged as opioids when they shouldn't be, or B, somehow got duplicated, perhaps, in a previous in a calculation in a previous step. E.g., the fact that you have a data frame called scripts chem suggests to me that you may have performed a join. Keep in mind that if you find multiple matches for a row during a join, that or dropped, join will duplicate those rows. Likewise, if no match is found and you're performing an inner join, those rows will be dropped. This could change your proportion and standard deviations. Since not all prescriptions have BNF codes that appear in chem. And also, I think in the chem table, some of the chem subs might appear more than once. Yep. And some chem sub in the chem table appear multiple times. My recommendation for this problem is to not perform a join, but instead to extract from the chem table all the BNF codes which correspond with opioids, and use that list of codes to flag prescriptions in the scripts table. This way, we can easily avoid accidentally dropping or duplicating any prescriptions during a join. Well, that's the last question on the message board. If any of you have questions for me live, I am happy to answer those. Of course, always. Otherwise, I will work on other things. If we could perform packing and unpacking of points examples. Sure. I think I have done this before, but I'm happy to have a look at it again. Weirdly, I can't access the hub. That's never happened to me before. So let me check what's going on there. Excuse me. Okay, the hub is running. So why can't I access it? Let's see here. Okay, I'll have to sort that out later. I'm not sure why that's happening. But what I can do is spin up a local Jupyter Hub, or not local Jupyter Hub, sorry, local Jupyter Notebook, and work from there. So we have point class that we've defined. And what the grader has some list of tuples. This is like what the grader has. Something like this. I mean, it's much longer than this, but you know, whatever. And then we have like lines of code that are like, or we'll call this a point list. And points will be a list of point objects. And all we're going to do is make a point object for X and Y in point list. Boom. Now we've got a bunch of points. This unpacking into X and Y can be performed another way. Instead of unpacking the tuple here into X and Y, I'm just going to refer to that tuple as point, and I'll unpack it here in the argument of the function. And it does the exact same thing. So that's two different ways of unpacking here. If we're passing a iterable into a call, a class call or a function call, we can unpack that iterable into the arguments of that function or of that class init method. So that's all that's happening there. Okay, yeah. I don't know why this is suddenly having a problem connecting. I'll have to investigate it after the office hour. I don't think I can fix it right now. Do you have any other questions about unpacking? I've talked about it like a few times, so I'm not really sure what more to say. But if you have a specific question, maybe I can be more specific in my answer. Should I study differential geometry to understand deep learning? No. Differential geometry is a very interesting topic, but it is in no way related to deep learning. The mathematics that are useful for understanding deep learning are not nearly so advanced as differential geometry. Vector calculus and linear algebra would be the most useful mathematics for understanding deep learning, probably followed by probability and statistics. Can we unpack the points in VC5 or is it forbidden? We do unpack the points in VC5. I mean, if you look at, let's see here. If you look at the code that we provide you in VC5, the very first thing that happens in the compute result function is that thing that I just showed you. This is exactly the same line that we had in the notebook I just had open. Except now point list, the thing the grader supplies, is now called points. But right away, what we do is we unpack those tuples inside the argument of a point class call to construct a list of point objects. So we already give you that code. It already happens. And in fact, it happens in every question. In every question, we're doing the exact same thing. You'll see this line repeated in each question. So it's in no way forbidden, and we actually do it for you. You should study, by the way, you should study differential geometry if you want to understand, say, general relativity. Differential geometry is like math that describes how to measure distances in non-Euclidean space, which mostly comes up in terms of applications in general relativity and not too many other fields. Yeah, so tensors, though, are not necessarily, tensors have a lot of applications outside of differential geometry. Tensors are also used, for instance, for the study of continuum mechanics and fluid mechanics, which, well, is a field of continuum mechanics. Tensors are useful for any linear algebra concerning objects of more than rank 2. So tensors are like a very generic mathematical object that find a lot of application outside of differential geometry. Can we view the points in printed form? Not the points from the grader. I have mentioned this before. I have answered this question before. The points that are used to assess your function are stored on the grader and are intended to be hidden so that you cannot compute answers by hand or by writing functions or something outside of the structure we're trying to make you conform to, which is the class point object structure, to solve the problem. We're trying to force you to solve the problem by defining this point object and defining its methods in the correct way. We're trying to guide you through writing a useful point class, and part of that is kind of preventing you from doing other things other than that would still give you the correct numerical solution. So no, you cannot print out the points. They are intentionally hidden from you. There's other questions in this course where you just submit a function to the grader, and what the grader actually uses, what data the grader uses to assess your function is not known to you. So your function better be correct. Okay, server appears to be back up. I didn't do anything, but it appears to be working again. They have tensor calculus in any part of deep learning. It depends what you mean by tensor calculus. I would say, strictly speaking, I mean, technically speaking, yes, but practically speaking, no. Deep learning mostly makes use of just gradients, which is a concept from vector calculus that can be generalized to higher rank fields, but you know, I can take a gradient of a vector function, I can take a gradient of a scalar function, I can take a gradient of a tensor function. But if I understand what a gradient does, I don't need to really understand anything particularly special about vectors or scalars or tensors, because I'm just taking partial derivatives of the various components of those things. So no, there's nothing like about covariant and contravariant transformations or anything like that. So there's nothing kind of unique about like dealing with tensors when it comes to deep learning. And even when you're doing deep learning, you don't necessarily need to like, it's not like you're computing derivatives. It's not like you're doing calculus in order to do deep learning. But it helps to have an understanding of vector calculus to have a clear picture of what's going on when you're doing deep learning. Cool. So that's going to be the end of the office hour. Thanks for joining me. Thanks for bringing your questions, and I'll be back tomorrow. Enjoy the rest of your day.